All right, this is lesson 3.9, lines with negative rates of change. We're going to start with a warm-up problem. So go ahead and read through that and then answer the questions on the warm-up. Make sure you pause the video, and then when you unpause, I will go through that warm-up. Okay, so hopefully you have your warm-up done. I'm going to show you what I did with mine. So basically what I'm looking for the table is that this table is decreasing by 2,500 every year. You do want to put the value at 25,000 at year 0. And then after the first year, it drops to 20,500, so on and so forth. So I just did 5 years. And then the basic idea with the graph, you didn't have to draw a sketch, but the main thing, the takeaway is that this graph, unlike the other ones we've done, is going to go downhill since it is a negative rate of change. Since the values are decreasing over time, the graph will go downhill versus uphill. All right, so this is a problem that was worked in groups, but the idea is to go ahead and work through the problem. So we have a water tank that holds 100 gallons of water. It leaks 5 gallons every hour. You're going to make a table and a graph that represents the volume of the tank over time. And we had graph paper in class. You can sketch a graph on this if you'd like, or if you have your own graph paper, you can do that. Just pick a scale that's appropriate. Then go ahead and go through and answer these questions. There was one question that is repeated twice. How do you know when the tank will be empty? When will the tank be empty? I guess they're technically different questions. So this last question asks when, so it's looking for a specific time. This asks how do you know when the tank is empty. So they are slightly different questions. So go through and answer those questions as best you can, and then I will go ahead and go over those on the video. All right, so hopefully you've created your table and your graph and have answered the questions. I'm going to go and show you what I've got for mine. So I just took the table out to 5 value, or well, I guess 6 if you want to count row 0. And then I just did kind of a sketch, and I labeled some main points with it. The first question was, how can we see the starting value in the table and then in the graph? Well, the starting value in the table, just like our other lessons, it's going to be specifically where x equals 0. It's a little too simplistic to say the top of the table, because somebody may have started the table that way, and then that's not the start value, right? So I want to be real careful that it's going to be when the x value is 0, then the y value is the start value. So how do we say start value on the table? It is the y value when x equals 0. Well, what about in the graph? Well, our start value is going to be up here at 100, right? So it's where it hits the y-axis. I'll put my y up here and my x over here, just as a reminder. And then this is the gallons, right? And then this is the hours. So it is the start value can be seen in the graph that seems too wordy. I'm going to make it a little shorter. I apologize if you started writing that down. I should be a little more efficient with that. This seemed really wordy. We'll just say it is where the line hits the y-axis. How about that? It is where the line hits the y-axis. Right, so right up there. All right, what does the slope represent here, and why is it negative? Well, the slope is going to be, well, we should be able to see it in the table, and we should be able to see it in the graph. And a couple of ways that we can see that is look at the values that's changing in the table. So this is decreasing, and it's decreasing by 5, so it's minus 5, while ours is increasing by 1. So our change in y over change in x equals negative 5 gallons over 1 hour. So it's decreasing at 5 gallons per hour. If we did a slope triangle here, now we've got to be careful. We've got to use the scale here. This is 25, but it's going down, so it's minus 25 over 5. And so if we do change in y over change in x, you get negative 25 over 5, which is really just negative 5. And you can say the same thing here. This is just negative 5 when you do negative 5 divided by 1. So that's really your slope. Now what does it represent? It is the rate at which water is leaking out of the tank. How do you know when the tank will be empty? Well, I guess we would say the tank is empty when y equals 0, because y is the number of gallons, right? Or when the graph hits, oh sorry, I apologize, I should have had this further up. The tank is empty when y equals 0, or when the graph hits the x-axis. Right? So here's your x-axis. When this line hits the x-axis, the number of gallons is 0. So that's how we know when the tank will be empty. Let's go and flip. The next question, what is the equation that of the line that represents the situation? Well, we know the start value is equal to 100 gallons, right? And we know that the rate of change is negative 5 gallons per hour, which is just going to be negative 5. So if we do our y equals rate of change, let's just use m and b because we've already talked about that. Remember, m is your rate of change, and b is your start value. And b is your start value. So it's y equals negative 5x plus 100. What is the volume of the tank at 12 hours? Well, I don't really want to extend my table all the way down to 12, and that's why we have the equation. So we can do our y equals negative 5, and in place of x, this is, I guess I should have wrote this up here or somewhere earlier, x is hours, and y is gallons. We want to keep that in mind. So if it's 12 hours, that goes in for the x value because x only represents hours. Plus 100. So that winds up being negative 60 plus 100, which equals 40. When will the tank be empty? Well, the earlier question is like, well, how do we know when the tank is empty? Well, when the volume, the number of gallons, equals 0. So why don't we plug in 0 for y? And now we can solve for x. We'll flip the 100 to this side. It becomes negative 100. We still have the negative 5x on this side. And then we'll divide by whatever's in front of x, which in this case is negative 5. So we get x equals 20. I did switch sides with this. I mean, this would be x equals 20. I just flipped it. You don't have to flip it. You can write it the other way. Oh, I apologize. Whew. This is like my third video lesson I've done today, so I apologize. I just got a little tired there. All right. So that is example 1, or the problem 1 that you guys were supposed to work. We're now going to take a look at another example. This is a gym membership. Now, this is going to be a little bit different in that we're actually comparing 2 different gyms. So we're going to actually have like 2 different lines. We'll have 2 different tables. It is possible to combine them into one table where you could have one X value, and then you can have a Y value or a Y column for each row. So it's your decision if you want to split them into 2 tables, one for each gym, or if you want to just do one big table and put the values in there. And then we want to know what would the equation that would represent each of the gyms, so each gym will have their own equation. So go ahead and pause the video, work on these on this problem here, and then unpause when you're ready to have me go over it. So hopefully you have the gym membership tables and equations and graph made. I'm going to go over the ones that I created here. So I decided I didn't want to do one big table. I know it was kind of set up for all the months here, and then you can do the gym memberships here. But I actually made smaller tables to kind of compare. So we can see this one decreasing by 10. So we'll put our minus 10 as the months increase by 1. Over here, this is decreasing by 5 as this one is increasing by 1. So here your rate of change is going to be negative 10 over 1, which is just negative 10. Over here, your rate of change is negative 5 over 1, which is just negative 5. I mean, you always want to put those in the simplest form if you can. We can see that the start values are up here at the top, where the months are x equals 0. So here's the start value row. So the start value is 250. And then same thing here. Start value is going to be on row 0. So right there. So 200 for one and 250 for the other. Based off of that, we should be able to write our equation, right? Our equations are y equals, and then the rate of change goes before the x because that happens x times. And then your start value comes after that, which only happens once. So basically we start at 250 and we subtract 10 for every month because x represents month. For the second gym, we start at 200. We subtract 5 for every month because x is the number of months. Then when I went ahead and created a graph for this, I did leave a couple things off. So this here is going to be the number of months, right? So x is months. I did not put this value in here. I guess we'll do that in a second. And then this is the number of members, right? Number of members. And technically we should have a title. So this would be membership comparison. Gym A versus Gym B. Hopefully that yellow line shows up okay. So this one here, this was Gym A, so the red was Gym A, and then the yellow was Gym B. Let's double check that on our table. Yep, Gym A started at 250, right, and Gym B started at 200. That sounds good. We do see that Gym A does start at a higher membership, but it is losing members faster than Gym B, which has less members, but it is losing members slower. There is a point here we see at 10, 150, where the memberships are equal to each other. So they both have 150 members. Our table actually didn't extend that far. I stopped at 6. So if I had kept going, I would have hit that at the same time when I got to 10. I just didn't take my table out that far. And then we can see after 10 that Gym A now has less members than Gym B. Let's go and answer questions then. So we'll start with, when do the gyms have the same number of members? And that's this point right here. So that would be at 10 months, both gyms have 150 members. So I try to be very specific on this. I'm wondering if I have another question here that's going to ask how many members, or when are the number of members the same? No, that is, no, I think this is fine. Sorry, I didn't even read this question carefully. When do the gyms have the same number of members? Okay, 150 at 10 months. I think we're good. Oh, so this actually, it asked when. So 10 months is really the answer to this. I did give the additional information of how many. So I don't know if if it asks later how many of those are. Let's keep going. How did you find the answer for part B? How can you find the answer using each representation? Table, graph, and equation. Well, I found this with the graph. So I found the answer. And now I can put my A for answer. I found the answer on the graph where the two lines meet. Right, and once again, on the graph, if we go to where the two lines meet, that is 10 months and 150 members. Now, that's the answer. They also want table and graph, table and equation. So my tables ended at 6. I had 6,190 and 6,170. So let's continue. 6,190 and 6,170. I'm going to continue 7, 8, 9, 10, 8, 9, 10. We'll just draw this out a little bit. This is gym A and this is gym B. So this is decreasing by 10. And this one is decreasing by 5. Sorry. Got to be a little careful on my, slow it down there a little bit. So if I keep extending the tables, I can see that at 10 months, both values become 150. And so those, I think, were fairly intuitive, just extending the table and looking at the graph. This one, you haven't been taught this, so I'm going to go ahead and teach you something that's kind of cool that you can do with the equations. The two equations, we have minus 5x plus 200. That's gym B. And we have y equals negative 10x plus 250. That's gym A. I did kind of reverse the order. But when the two memberships are the same, the y values are equal. So my question is, when will this expression be equal to this expression if the y values are the same? In other words, this is called the equal values method. This equation tells me the number of members from gym B, right? That's what y equals, is the number of members. So this expression's equal to y, so this expression is equal to the number of members for gym B. If I take this, which is the number of members for gym A, and set it equal, if I solve this equation, it should tell me what value of x, or in other words, how many months it will take for the memberships to be the same. First step, flipping. I'm going to take negative 10x. I'm going to flip it on this side. I did it this way because this is going to create a positive value here. If you set them up the other way, you'll still get the same answer. I still have the 250 here, but this 200 has to flip to this side. Here I have a war, which gives me a 5x. Here I have a war, which gives me a 50. And if I divide both sides by 5, I have x equals 10 months. So this is called the equal values method. I'm just introducing it in this lesson. We're gonna do, the next lesson is gonna cover this a little more in depth. I'm gonna apologize. I wound up creating this lesson and I labeled this 3.9. I have another lesson that's also labeled 3.9, so I apologize for the confusion that might cause. I'm gonna just relabel it, have you just make it a 3.10. Which is the last lesson for this unit. And in that lesson, we're going to explore this equal values method a little bit more. How are the situations different from the problems we've looked at before? Well, this situation, the rates of change were negative. And the graphs went downhill. Where else in real life do we see similar relationships? And that's, it's kind of an open-ended question. And so in class we would have discussed that. Some that I can think of off the top of my head, if you are, let's say you have a lunch account and you eat lunch every day, so you pull money out of that account. Toll roads kind of work the same way. Some systems have where you put $50 into the account, and every time you use a toll, they'll subtract out whatever that toll is. The amount of gas in your car, so as you drive miles, the amount of gas in your tank decreases. So pretty much any type of situation where you have a consistent decrease of the same amount each time. So a gas tank isn't the best example unless you are driving consistently at the same speed. Then the amount of gas you're using should be fairly consistent. Like the lunch one, if you have a lunch account, you have to be pulling out the same amount every time for you to get a nice straight line that declines at a constant rate. All right. Now the last problem is one for you to do on your own. So this is a phone battery, and it is 90% charged, and it loses 3% per hour while playing videos. What would be the equation for the scenario? And then if the battery was at 90% at 8 a.m. this morning, so specifically what time would it be at 30%? So step one is you need to be able to build the equation, and then you're going to have to find the equation, use the equation to find how long it's going to take for the phone to go down to 30%. And then you're going to have to take that answer and think about, well, what time would that be since it starts at 8 o'clock? So the answer you get here, how many hours it's going to take, isn't your final answer. You have to give what time that's going to be if it was 90% at 8 a.m. So go ahead and pause your video, work through that problem, and then I'll go through the answers. Okay, so hopefully you've paused and you worked through this problem here. I'm going to go ahead and start with it. I'm going to start by defining my variables. I have two things that are going on. We have time as a variable, so x is going to be hours, the number of hours it's been since it was at 90%. And then y is going to be the percent charge on the phone. Your start value was given to you at 90%. And your rate of change was given to you. And your rate of change is negative 3% per hour. So from this information, we should be able to write our equation. Y equals, the rate of change is negative 3. X is the number of hours, and then we always put our start value by itself. So the rate of change goes next to the x, the start value goes by itself. That's your equation. And now you want to find out, well, when is this going to be at 30%? So where does 30% get plugged in? Well, it is the percent charge, which is y. Y represents the percent charge. And so we're going to replace y with 30%. I'm not going to write the percents on there. It's unnecessary to have them on there. And then we're going to solve for x. Remember, x is the number of hours, so it makes sense that we would plug 30 in for y, and we would solve for x because we're trying to basically find out how long it took the battery to go from 90 to 30. Now let's go and do our math. We're going to flip the 90 over. It becomes a negative 90. 30 stays the same because it never moved. Negative 3x stays the same because it never moved. We have a war here. Negatives win with 60 left over. And then we're going to do our last step, which is dividing. We always divide by whatever's in front of x. Here's a negative 3x. So we will divide by a negative 3. So we get x equals 20. So that's 20 hours. That's how long it's going to take for that phone to go from 90% to 30%. Sorry. Forgot to scoot up that paper. Now, so how are we going to figure this out? At 8 a.m., it was at 90%. If we go 12 hours, that's 8 p.m. Right? So 12 hours, we need 20 hours, right? So this is going to be 12 hours. If we go to midnight, 8 p.m. to midnight, so 12 a.m., that's another 4 hours. So now we're at 16 hours. We need 4 more. So if we go 4 more hours, that's going to put us at 4 a.m. So that is your answer. The phone will be at 30% at 4 a.m. All right, that is the end of lesson 3.9 on negative rates of change.